This thing's called characteristics, but if you want to call it graphing part 2, it's kind of, that would work too. Linear functions. Who can give me an example of a linear function? What kind of shape does a linear function make? Yes, not necessarily horizontal, but yeah, it's a line. What's the equation that looks like a line? Y equals x? Sure. How simple can you get? There's one. Okay, what do we know about these? What's a degree? A linear function is what degree?
1.
Good. That means the power on x, right? It's x to the 1 power. That's what makes it straight. And how many x-intercepts could it have? Picture a line. How many times could it cross the x-axis? That's it. Could it cross it no times? Okay, so that's an option 2. Could it ever cross it twice? No, because if it did, it would bend and then that wouldn't be a line anymore. Okay? So 0 or 1 x-intercepts. And you can always make the argument, yeah, what if it is the x-axis? Then you could say, well, does it cross it? There's infinitely many x-intercepts. Okay, there's always an exception, right? Okay, what's kind of new is end behavior. Is it a good one or a bad one? What's its behavior? Well, there's a bit of a pattern here. I'll tell you in a sec. But a positive line, you know what shape that makes? Can you picture it? Which way does it tilt? Top of the line tilts to the top.
First quadrant.
All right, you're into quadrants. Good. Top of the line tilts to the right. That's positive line, right? Anything just off horizontal, because the slope of that's 0. Anything right up to vertical, because the slope of that's undefined. Anything from here to here, that's positive slope, right? Therefore, anything like that's negative slope. Okay. Someone stole my quadrant word, though. So positive. And when I say positive, I mean the leading coefficient. Because now when we got cubics, we got x cubes, we got x squareds, we got x's, we got constants. What do we mean positive? We mean the leading coefficient. Because it's not always going to be written in the right order, right? You don't just look at the first one. Don't write this down. But if that's f of x, is that positive or negative? Now, is it positive or negative? It's positive. You don't look here. You look at the biggest one. What's the positive leading, what's the leading coefficient? The coefficient here is a 1, it's a positive. We don't write the 1, right? So that's not in the right order. Don't expect us always to put it in the right order. So the leading coefficient. So for an example, I mean, f of x is x. Yeah, that's the simplest as it gets, but maybe something more familiar that looks like y equals mx plus b. It's not y anymore, it's just fx, but that's what that says. Okay, what does that look like? Well, you know, you start with a y-intercept, -2. It's got 3 units of rise, 1 unit of run. That looks something like that. Okay, without even drawing a grid. Is it positive? It is. Does it tilt to the right? Yes, it does. Could I graph that quickly? Yes, I could, but I'm not going to bother. Okay, so thinking of quadrants, what quadrants does that go in? The end behavior.
1 and 3.
It goes up in 1 and it goes down in 3. Yeah. Okay. So we didn't really care about that in grade 10, but you know, now in grade 12 we can describe it a bit better. So that's if it's positive. What if it's negative? A negative line. You knew that as if the x term was a negative. Okay? Negative. but we still want to say what's negative, not the constant, not the number. Okay, negative 1/2 x. I don't care about the 2 here, the constant. I care about the x term. That's the leading coefficient. Okay? And we know that guy looks like, well, more exactly, half would be a lot flatter than 3. So that's what that thing looks like. Negative slope tilts the other way. What quadrants are we talking now? Two and 4. Okay? That's linear. That's grade 10. Grade 11, quadratic functions. They have degree, what? Yeah, these were all degree 1, right? 1, 1. If you put a square on there, it makes it do a funky parabola. And how many x-intercepts can you have? Could you have 1? Okay. Could you have none? Yes. We're all okay with that? You can visualize it? You remember it? Don't need any pictures? Yeah, so you could have 0, 1, or 2. Is that the most you can have? You can't visualize a parabola crossing the x-intercept in more than 2 places, can you? Whether it opens down or whether it opens up. Do you notice a little pattern here? Way, dude. Okay, quadratic function. Yeah, there's a little pattern. Let me move that page bigger. Okay, end behavior. We never talked about this last year, but if it's positive, okay, I'm going to abbreviate. Leading coefficient, okay, for an example, function of x is 2x squared plus x minus 1. Okay, there's a negative there, but the leading coefficient is positive. Okay, maybe we don't remember how to plot that thing, but I think we're pretty sure that what way does it open? Yeah, and if you don't believe me, pull out your graphing calculator and have a look. Might want to note the constant's minus 1. Where's the x-intercept or the y-intercept here? Negative 1. Where x is 0, what are you left with? Negative 1. But all I'm concerned about right now is end behavior. What quadrants is this?
Is it counting?
Well, even if that's my grid, eventually this thing's going to be going where? In this quadrant, right? So it doesn't really matter where this grid is. Sooner or later, it's going to go in quadrants 1 and 2, okay? Up. Because you know it goes out forever and ever and ever. That's why our domain is all real, right? Okay? Well, why did they go counterclockwise? Yeah, I can't answer that question. I don't know. Oh, stupid. That's positive. If a positive quadratic opens up, then a negative quadratic, the negative leading coefficient, for example, will go which way? Yeah. I don't know, plus 1? Yeah, okay. So it might be a little fatter, it might be a little skinnier, it might have a different y-intercept. Maybe it's moved around a bit, but eventually these arrows will end up in quadrants 3 and 4. Okay? So far, so good? Okay, what's the new thing called? Cubic function. and I did mention this yesterday, but let's put it in here again. What's the degree on a cubic function? 3. And how many, what's the maximum number of times you think it'll cross the x-axis? Yeah, some of us like patterns. So, well, that's a good question. Could it be 0? So it could have 3. Could it have 2? Well, what do these guys look like? Here, let's get an example. Positive leading coefficient, like for example, f of x is, that's positive, minus x squared. I could have all of this stuff, I could have none of it. Okay, it just affects its shape a bit, makes it a little more curly. Actually, it kind of affects how many x-intercepts you're going to have. Okay, but let's see what that guy looks like again. Let's go x to the power of 3 minus x squared minus x minus 4. That's got how many? Okay. So I'll just tell you, this thing, if the simplest one you could possibly have is that, right? Do you know what that would look like? It would go right through the origin, right? If x is 0, right, that's how we find the y-intercept. It wouldn't have all this extra stuff in here. That's what all the x squareds and the x's and the number does, okay? Guess what this is? That's the constant. That's minus 4. That's your y-intercept. Okay? But all this x squared and x stuff, that makes it more funky in here. But it's always going to do what? Go up in quadrant 1, down in quadrant 3. So it always has to cross the x-axis. You can't have 0. But you can have 1. Okay? I could have 2. I don't have an example of that, but it could go up and just touch it, come back down, and then go up again. Okay? So I talked about it. Let's actually have a look. The simplest one, cubic, you could ever have is just x cubed. Let's compare that to the one I just had. Okay? So there's no funky stuff going on. It just is a nice curve up to the origin, and then a turning point, and it curves back up. But a positive leading coefficient always will go quadrants 1 and 3. Okay? You remember the line? A positive line? Do we notice something about its quadrants? Yeah, that's an odd function. This is an odd function. It's similar. Okay? So if you're trying to remember this on a test and you can't really figure it out, it's consistent in that way. So if it's negative, what quadrants did it go in? For a line, okay, a degree of 1 went in quadrants 2 and 4. So a cubic, an odd degree, 3, Lewis, goes in what quadrants? It's consistent. That's 1 and 3. Negative will go in quadrants 2 and 4. Okay, for an example, negative, I don't know, let's do something weird. 1/10 x cubed negative bracket 1 divided by 10 bracket x cubed. It doesn't matter about all this extra stuff. Okay, all that does is make it more interesting around the origin. But that shape will always go quadrant 2 and 4 if it's negative. Okay? It'll get a lot more interesting with the x squareds and the x's, but it'll always go up there and down there. It's a little fatter because it's 1/10. Okay, so we want to maybe note that is the constant, and what was the significance of that? That's the y-intercept, right? Last year I taught you, well, what happens at the y-intercept? X is 0, let it all be 0. What are you left with? Just the number, the constant. But now, I mean, you don't even need to do that step. Just have a look. That's the constant. That's the y-intercept. Okay? So, negative looks like that. Positive looks like that. Maybe it's got something funky going on, but it always does that. Okay? That's about it. $3.93. 1 to 3. Yeah, there's not too much new stuff. No. Now I said no graphing. Why did I say no graphing? Because you should know by looking at it.